we have studied about the structure of the triple bonds, the isomerism and preparation of alkynes. Now we will move on to the physical and chemical properties of alkynes. So, let us discuss the physical properties of alkynes. Okay. So, first property is all alkynes are colorless. Okay. The second property is ethyne has a characteristic odor but all other alkynes are odorless. Okay. The third property is about the phases. So, C2 to C4, that is ethyne to butane, they are gases. Next 8, that is C5 to C12, they are liquids, and the higher alkenes, higher alkynes are solids. Okay. Next, the next property is that melting point boiling point and density of the alkynes increase with an increase in molar mass. So, basically the higher alkynes will have a higher melting point, boiling point and density. The next property is alkynes are more polar than alkenes and alkanes. Okay. Then alkynes are lighter than water, that is their density is lower than water and immiscible in water. Naturally, water is a polar solvent, so generally water dissolves highly polar molecules. Alkynes are more polar than alkenes and alkanes, but still the polarity of alkyne is pretty less. So, alkynes are immiscible in water. So, they are soluble in organic solvents like ether, CCl4, benzene, etc. Okay. So, alkynes are soluble in organic solvents. Now, we will discuss about the chemical properties of alkynes. Okay. So, the first chemical property is the acidic nature of alkynes. So, alkynes are slightly acidic in nature. The reason for this will be discussed now. So, one example is this, that we have ethyne and we react ethyne with sodium metal. So, it gives this anion which is known as the alkylite ion. Okay. Alkylite ion, and there is one sodium plus. So, this one is known as monosodium ethynite. Okay. So, sodium metal and sodamide, they are strong bases. So, in their presence alkynes react to give an alkylite ion by the liberation of hydrogen, and we know that the liberation of H plus is a nature of acids. Liberation of H plus is a nature of acid. Okay. So, along with it we will get half H2. Okay. So, again there is one more hydrogen here. So, again if we react with another sodium metal, we get that is Na2C2, and again we get half equivalence of hydrogen. We call this as disodium ethynite. Okay. Now, if we take propine for example, and we react this with sodamide. So, sodamide here Na plus and NH2 minus. So, NH2 minus will take one hydrogen and we will get this. Okay. We will call this as sodium propionate. And along with this, since NH2 minus is taking this hydrogen, so we get one molecule of ammonia. Okay. Now, what is the reason behind this acidic nature? So, alkanes and alkenes were not that acidic, because alkanes and alkenes had lower S character. So, alkane were sp3 hybridized, alkenes are sp2 hybridized, and alkynes are sp hybridized. So, we see that gradually the S character of the hybrid orbitals are increasing, and with the increase in S character, electronegativity also increases. So, alkanes, they were sp3. So, in sp3, so sp3 means 4 orbitals, among which there is one S, that is one orbital has more S character. So, in sp3 orbital we have 25% S character. Okay. Now, for alkenes, the alkenes were sp2 hybridized. So, alkenes have 33.33% S character. Now, alkynes have sp hybridization. So, this is 50% S character. Okay. So, with the increase in S character, electronegativity increases. So, higher percentage S means higher electronegativity. Okay. So, what happens? Higher percentage S means higher electronegativity. So, in the alkyne, that is in this CH bond of alkyne, C will draw the bonded electrons more. Okay. So, for alkynes, since the carbon has higher electronegativity due to higher S character, so it will attract the bonded electrons more. That is, the negative charges are more concentrated on carbon. Negative charges are more concentrated on carbon. Therefore, hydrogen can be liberated easily. Okay. So, this is the reason behind the acidic nature of alkynes. So, if we compare the trend of acidic nature, this is greater than this, than this. Okay. Also, if we compare between different alkynes, this is greater than this. Okay. Now, the second chemical property of alkynes are the addition reactions. The addition reactions of alkynes are quite similar to that of the alkenes. Alkynes will also add to hydrogen, halogens, hydrogen halogens, etc. But for alkenes, we required one molecule of these reagents, but for alkynes, since there are two pi bonds, we will need two molecules. Okay. So, how the addition happens? We have this triple bond, and let us say we have HZ, where H has a partial positive charge and Z has a partial negative charge. So, one pi bond will break and it will attack on the hydrogen. So, we will have this type of vinylic cation. Okay. Now, the carbocation can form between either of these two carbons. Then again we have Z minus, so we get this. Then again if we give another molecule of HZ, then we will form alkanes. Now, the question is, like in the alkenes, we had seen that Markovnikov rule was followed. Similarly, for alkynes also, this stability of this vinylic cation will dictate the formation of the products. Okay. So, product formation depends on the stability of vinylic cation, okay, and similar to alkenes, for unsymmetrical alkynes, Markovnikov rule is followed. Okay. For unsymmetrical alkynes, Markovnikov rule is followed. So, since like alkenes, alkynes also have pi electron cloud, that is why alkynes are electron rich, and due to being electron rich, they will react with electron deficient species. So, what we call the electron deficient species? We call them electrophiles, that is those species which love electrons. So, alkynes will undergo majorly electrophilic addition reactions. So, alkynes undergo electrophilic addition reactions. Okay. So, the first one is addition of hydrogen. So, this is also very similar in presence of metal catalyst. Okay. So, if we take one alkyne and we have hydrogen and we take metal catalyst such as platinum, palladium or nickel, then we have already discussed this method multiple times, that we have this metal surface and the alkynes will be adsorbed on the metal surface and hydrogen will also be adsorbed on the metal surface, and such syn addition occurs. Syn addition. Okay. So, if in place of hydrogen we had some other group here and we are adding hydrogen, so it will be like this, that is both the hydrogen will add from the same side because they were all adsorbed on the metal surface. Now, this alkene is formed by addition of one molecule of hydrogen to alkyne. Now, again we have hydrogen and we have metal catalyst. So, again one molecule of hydrogen will be added and we get alkanes. Okay. So, alkynes to alkenes will take one molecule of hydrogen and alkynes to alkanes will take 2 molecules of hydrogen. So, in the next lecture we will study about more reactions of alkynes and then we will start aromatic hydrocarbons. Thank you.